Hello friends, in this video I am tearing down an old SATA hard disk drive, and further we will have a look what resides inside the hard disk drive. These drives are very precisely built, and if you will open up a working drive, it will get corrupted or destroyed after getting exposed with the outer atmosphere. These drives are manufactured or assembled in a completely dirt-free chamber. People are wearing a proper lab clothing before entering the unit. So here I am opening all the screws on the drive to remove the upper metallic cover. So I am making this video fast forward to save the time. I will leave the corner screw since it is completely wear out, and just I will twist the upper cover to access the internal part of the hard disk drive. Before moving further, I would like to have a proper view of internal parts of hard disk drive. In further video, I will tell you what all these parts are and how they are working. So let's check out the well-labeled diagram of the hard disk drive. So first is a spindle, second is slider and read-write head, then actuator arm, actuator axis, actuator, plater where data is getting stored, ribbon cable attaches head to logical board, debris filter, base casing, read-write head support stand. So this hard disk drive is of Hitachi brand and it's of 160 GB capacity, and its RPM is 7200 RPM. So this is actuator arm, and on the thinner side read-write head is connected. On the other side there is a neodymium magnet on the top and the bottom. In between of that neodymium magnet there will be a voice coil which is attached to the actuator, and whenever the deflection happens, then the actuator arm is moving to and fro and even over the platter to read or write the data. So these two neodymium magnets are basically on the top and the bottom. So these are the permanent magnet. You might be knowing this neodymium magnet. So the voice coil of actuator arm is connected to this logical IC via the ribbon cable, and actuator will move over this platter like 22 times in a second to read or write the data. It moves very fast on the top of this platter to read or write the data, and this platter will rotate 7200 times in 1 minute. That is known as 7200 RPM. So this actuator will move over the platter whenever the platter will rotate with the required speed. Otherwise, the platter will get scratched with the read-write head. It should be rotating at the required speed so that the actuator arm read-write head should be hovering over that platter. Just a minute air gap will be there. And simultaneously, read-write head connected at the end of actuator is reading or writing the information on platter, which we call as data. So this is the air filter which protects the hard disk drive from external dust particles. You might have seen a small hole on any hard disk drive with an info written beside it. Please do not cover this hole, which means when hard disk drive is rotating at a speed of 7200 RPM with read-write arm moving over the platter, need presence of air inside the drive to keep the read-write head hovering over the platter. This also protects the platter from getting scratched. And this is the main reason why computers should properly shut down and not to be powered off abruptly from the wall switch. Read-write head will stuck on the platter due to sudden powering down the computer from the wall switch. In result, it could malfunction the hard disk drive, or even it could damage it permanently. So whenever you are shutting down the computer in a proper manner, the read-write arm will move to its default position, securing the read-write head under the plastic covering. Then platter will get slowed down and stops. So this is the reason why we need to have a UPS along with the desktop. However, UPS also protect the computer from power fluctuations. I am taking out each mechanical part from the drive to make you understand in a better manner. So this is the platter, and for your information, the data is written on the both side of the platter. Therefore, one read-write arm is having two read-write heads. Both read-write heads work simultaneously on the either side of the platter during the arm movement. I am removing the plastic covering which protects read-write head when the read-write arm is at default position. So this is the ribbon cable which is connected to the read-write head and going to the logic board on the back side of the hard disk drive. This is the neodymium magnet. That's the permanent magnet, you might have heard about it. And let me just take out each and every part now. First of all, let me just take out the platter. So this is the platter. So this hard disk is having single platter inside it since it is of 160 GB. But nowadays there are many hard disks with multiple platters fixed one on the top of other with a certain gap. So there is one more air filter sitting beneath the platter. In the meanwhile, I would like to explain you how data is written on the platter or disk. Data are getting stored on concentric tracks available on the platter or the disk. During manufacture, up to 200,000 tracks are created on the disk. These tracks are divided into several sectors. A map of the track and the sector tells the circuit board where it needs to read or write the information. Though the surface of the disk looks so smooth and shiny, however, if you will look closer, it's a way more complicated. A magnetic film on the surface of disk memorizes all the information. The information on the disk is getting stored in the form of bit, that is 0 or 1. Seeing the tracks more deeply, you will find small magnets arranged in a row forming the tracks. While storing the information, bit level values, that is 0 and 1, are determined by the orientation of the magnetic field of each magnets on the track. It doesn't take too much time to change the magnetic field orientation as read-write head is moving with the lightning speed that could be up to 60 times in a second, with a very small air gap which is likely to be 5,000 times thinner than the human hair. It's too small gap, and in the same manner it reads the information. One high quality picture could take up to 30 millions, that is 30 lakh bits. This sounds extremely massive, however in reality bits can be stored in really small space. Each 2 cm square on disk surface holds 31 billion, that is 31,000 lakh of bits. A hard disk drive can store several information in very small space using the electric and magnetic power, and this is incredibly amazing. So this platter is very rigid and hard. However, the magnetic film coated on the platter is very sensitive and delicate. I am taking out the clip of actuator arm to take it off from the chassis, and this is the separator. And here I am taking out the upper neodymium magnet, so here it is. Now you can see the coil fixed with the actuator arm very clearly. I am taking out the actuator arm as well, and you can see the ribbon cable attached with the actuator arm, which is finally attached to the read-write head. As I told you earlier, there are two read-write heads in one actuator arm to read or write the data on both sides of the platter. And this is how the deflection in the coil moves the actuator arm over the platter to read or write the data. This works on the same principle on which DC motor works. Motor is having the arrangement for circular movement. However, here it is to and fro movement. And this is how the hard disk drive works. Hope you like this video, and if you feel this video is informative, please hit the like button. Share this video with your friends and family, and do subscribe my channel for the upcoming videos. And yes, to get quick notification about my videos, don't forget to press the bell icon. See you in the next video. Take care and bye bye.